I'm going to give you the value of a trigonometric function and the angle in which the terminal side lies. We're then going to use that information to find the remaining 5 trigonometric functions of that angle. So we're given that the sine of theta equals 12/13, and we're told that theta lies in quadrant 2. Since we know that the sine takes as input an angle and gives as output the y-coordinate, we know that y is equal to 12/13. In addition, because the angle theta is in the second quadrant, we know that x is going to be a negative quantity because x values are negative in the second quadrant. What we're going to do to find that value of x is use the fact that the terminal side of the angle lies on the unit circle x squared plus y squared equals 1. So that x squared equals 1 minus y squared, or x equals the negative square root of 1 minus y squared. Again, it's the negative square root because theta is in the second quadrant and x values are negative in the second quadrant. So what is this x value? It's negative square root of 1 minus 12/13 squared. So what I have is negative square root of 1 minus 144, that's 12 squared, over 169. That equals, so x equals negative square root, this is 169 over 169 minus 144 over 169. That gives me 25 over 169. So I have that x is negative 5/13. Now that I know x and I know y, I can use the definition of the trigonometric functions to find the values of the remaining 5 trig functions. So again, x is negative 5/13, y is 12/13. We already know sine of theta is 12/13 because it was given. The cosine of theta, remember, the cosine function takes as input an angle and gives as output the x-coordinate. So the cosine of theta is negative 5/13. The tangent of theta takes as input the argument theta and gives as output the ratio of y over x. So I have 12/13 divided by negative 5/13. The 13s cancel, and I'm left with negative 12/5. Then we can have the cosecant of theta. Remember, the cosecant takes as input the angle theta and gives as output 1 over the y value. So I'm going to have 1 over 12/13, which is 13 over 12. The secant takes as input the angle theta and gives as output 1 over the x-coordinate. So that's 1 over negative 5/13. So I get negative 13 over 5. Lastly, we have the cotangent, which takes as input the angle theta and gives as output the ratio of x, which is negative 5/13, to y, which is 12/13. So we have that the cotangent is equal to negative 5 over 12.